So please excuse the noise in the background, that's my 3D printer running. It's been on a 4-day long print. We're on 97 hours so far. And it's almost done, but while that's been going on, I've been working away on this Bridgeport TC22 transmission or gearbox, however you call it. So this thing's fully rebuilt now. It's a bit of a nightmare, as I said in previous videos, because every single shaft on the thing is heat shrink fitted to the gears. So it's caused me a bit of fun, but it's back together, and all the bearings are new, all the gears are new. The backlash is like dead on it, and the horrible whirry noises that were coming from it before I rebuilt it are gone. So hopefully it won't be making noises when it goes back on the machine. But this video is about the gear engagement system and the locking mechanism on the torque cut transmission. I thought this would be useful for some guys out there with a machine. So the way this transmission operates is you've got your motor that comes in the top here through this hole. So if you look over there, you'll see there's the motor that sits on top with the gear on there, and that comes down through this hole and engages either this gear here or this gear over here. So you've got these two lay shafts. Now one of these is a 1-to-1 ratio, this one here. So whatever RPM the motor spins at will be whatever RPM the output shaft of the gearbox spins at. Now this one here is geared down at 4-to-1, so for every 4 turns of the motor the transmission is going to do 1 turn. So when you're at low speed you're in this 4-to-1 here. Now the way it engages is this whole mechanism that's holding the lay shafts rotates, and here we have the rotary actuator, and what happens is pneumatic pressure comes in on these valves either side, and that causes this whole assembly to rotate. So I can do a little bit of a demo. So if I take the air gun, you can see that rotates. Now this is this whole assembly is not concentric to the shaft, so essentially as this moves around, that's what allows the gears to engage and disengage. So you can see it goes back and forwards. It moves pretty quick. You know, these guys that say that they're having issues with their torque cut changing gear, you know, this thing changes gear no time whatsoever. I'm putting about 80 psi in this, which is what the machine needs, and it whips around pretty quick. So once that's in place, down lower in here there's holes in the mirroring plate like this down in the bottom. It's got a hole in it, and to lock the system in gear they have what's called a shot pin. So it's just a pneumatic linear actuator. So this one is made by SMC. So you know, you can go on Bridgeport parts and pay $400 for it, or you can go on somewhere like McMaster-Carr and buy one for $40. And I think if you look in my photo gallery there's some images of the models of what you need. The only difference is the one you buy from them, there's a little hole down here where it's screwed in. You could drill and tap it if you want to. It's not that critical. I just put a cable tie on it because this actual piece up here actually holds the thing in really nicely, so it's just to kind of stop it flopping a little bit, but it didn't move a lot anyway. Now to engage the shot pin and lock the gears, you just put air pressure on this lower hose and it will lock in. And let me just put you on the mount for a second. So I've got both my hands. I'll tilt you down a little. So all this is a reed switch sensor, and you just need to apply a little bit of voltage. So over there I've just got a little lab power supply. It's putting out about 8 volts now, and as you can see, I've got it wired up down here. Now what I've done is I've put just a little resistor in there just so there's some kind of load on it. I don't know if it really needs load, but I put some on it anyway, just so we're not like short circuiting this reed switch. Probably is not a good idea to short circuit a reed switch, even though there's some brains in there and there's an LED. I figure let's put a load on it. So when I come along here and I engage the shot pin, you see the LED come on. Now the way that does that is there's a reed switch in here, and on the actual, like the piston inside the cylinder, there's a magnetic block on it. So when the piston gets up to the right point here, the magnet activates the reed switch, and that makes the circuit. And then the system knows that the shot pin's actually locked in place. So some of you guys who are having trouble with the shot pin engaging, it could just be that you need to undo this little Allen here and just move this up or down, and you can take these tubes out. You just push down like this and they come out fairly easy. So it's not going to come out now that I said that. See the top one. No, they're well stuck in there now, but take my word for it, it's easier when you're not filming. You can get these tubes out and just put some air and move the shot pin up and down once you know you got it in the correct gear. And you can fine tune this by moving it up and down, so it's pretty easy. You can actually get the shot pin out without removing the gearbox from the machine. There is just enough room. The problem is that your oil is all the way up to here, so you might want to change your shot pin and coincide it with a oil change. Now the oil drain is actually lower than the shot pin, so you should be able to drain the oil out from here and change the shot pin over there. So what you have to do is, if you take this lower air fitting out, you can actually unscrew this air fitting here, take this whole sensor assembly off, and you can get a little wrench on there and just turn it, and it will spin down. And there's actually enough play in there just to unscrew that and get it out sideways. So you haven't got to take the whole gearbox apart or take it out of the machine to change it. It's in a less accessible area of the machine because you've got to take the covers off around the spindle, but you know, you can get in there and do it if you have to. Now this turnac that's up here, the rotary actuator that turns the whole gear assembly inside the gearbox, that's a little bit more tricky. If you want to rebuild it, some guys have just taken these bolts out the top here. So you've got these 4 bolts, and when you get those out, you can lift this whole assembly off, and the shaft with the seals and the vanes comes on out. And the problem you've got is that the gear is still down in here, so you can't actually get the shaft out. So what you end up doing is you undo these, and then you would have to actually remove this part out, but it's a bit of a pain. So the easiest way to do it is to unbolt the motor, undo these 4 bolts that hold this top plate on, and just take this whole top plate off the machine, and then underneath you can get these opposing bolts out, and then you can rebuild it properly. Because if you don't, in this lower section here, there's actually there's some seals in there that you wouldn't be able to replace if you didn't take the whole shaft out. So best bet's to do it properly and take it all out. But I know there's a couple of guys on the forum that have actually managed to kind of change most of the seals, just not some of the end shaft seals, but the actual rotary vane seals you can get in there and change kind of without having to take too much apart. But you know, I had this all off, so I just did it. Now again, on the machine, it needs to know where the gears are, like what gear it's in. So we've got the shot pin sensor down here, which is a reed switch, but then at the top we've also got these reed switches that sit on the top of the rotary vane actuator. So they're exactly the same in terms of power and everything as this little guy down here, but as this turns around, these ones will come in. But I've tested it, and with the gearbox off, I've actually tuned it and got these back in the right places. So as it rotates backwards and forwards, you can see that it's in high or low gear, and that just sends a signal to the machine, says, hey, I'm in high gear, I'm in low gear, I've made my position. Once it makes its position, then the shot pin comes in and engages. So sometimes you'll get an error saying shot pin, but it could be that this sensor here, like one of these two, is not quite in the right place. So this top plate assembly here is not rotating all the way around. And when it doesn't rotate all the way around and get fully home, if this thinks it has, but the hole for the shot pin's not quite lined up, the shot pin will try and go up, but it won't go in, and then you'll get a shot pin error. So it could be that this isn't making it to where it needs to be, and the shot pin's not going in, or it could be that the little sensor down here on the shot pin's in the wrong spot. But the first thing you can try is this one, and you can hear it go in and out. It's kind of, you can hear it like it clunks because it's metal on metal. So I hope that kind of helps some of you guys understand a bit more about how that gear change mechanism works. It's really simple, really rudimentary, and you know, it should be very easy to fault find. Now, this was struggling to change gears unless the machine was warmed up, and when I took it all apart, the oil in here was like nasty, real nasty, and it actually got to the point where it got sticky. So I think what happens is the oil that the manufacturer recommends, that Bridgeport recommend, I think after a certain amount of time, it loses its shall we say lubrication properties, and then we end up in a situation where it actually becomes sticky, and then when it warms up, obviously it becomes less sticky, and then it changes gear nicer. So I'm actually going to put a different oil in this gearbox. I actually called the company Gear Technic who made this transmission for Bridgeport, and I'm going with a more modern oil than what Mobil make, and it's still about the same kind of money. It's not cheap stuff, but it's a fully synthetic differential oil, and it's a little thicker than the original oil, so hopefully that should help with the noise. But because of its more modern properties, it can be thicker but still give the same level of efficiency. So I'm going to try it out. It's still a Mobil oil, it's just a newer, more modern oil. If it works out well, I'll probably tell you what it is. If it doesn't work out well, I won't tell you what it is, because I don't want people blaming me for the gearboxes chewing themselves up. But this did 26 years, and the gears were kind of worn. They weren't worn out. They was getting towards being on their way to well worn out. So it's starting to get noisy. So, but it's all rebuilt. It's got new seals, it's got new bearings, it's got new gears. All the shafts were checked to make sure they're running true and straight. I've cleaned everything off as best as I can. You know, it's been gone through degreaser. I put some bits in the dishwasher. You know, I got it as clean as I possibly can inside, so hopefully there's no debris in there that gets in there and ruins the brand new bearings, because they weren't cheap. And we'll see how it runs. Now, one thing you got to watch out for when you rebuild these, in the top here, underneath these circlips, there's some shims. So from the factory, they put these shims in to take out the play in the shaft, so because you could lift this up and down. So the shims that were in there on the smaller bearing were fine. There was 2 shims in there, and they was, what was the size? 0.3 millimeter shims. Now on the bigger bearing there was only one 0.3 millimeter, and in the smaller bearing there was 2 0.3 millimeters. Now this was still loose with the 1, so I went on McMaster Car, and they sell all these shims. They sell these circlips, they sell the spring washer that goes underneath They sell the seals. They basically sell all the little ancillary parts that you could possibly need. But McMaster Car are great. You know, I went on their website at 5 p.m. I ordered the pieces I need, like the seals and the shims and the new circlips, and they all arrived the very next day. Like, I mean, 11 o'clock the next morning. I ordered it at 5 o'clock p.m. the previous day. So super fast, excellent service. Can't recommend them more highly. The other issue that you may have if you want to rebuild one of these is the main, let me see if I can lift it here. So that's the main output here. Now this is a compression fitting, so as you tighten this nut, it pushes in and pulls out at the same time, so it clamps the shaft and pushes out on the pulley. Now you need a 32mm spanner or wrench that will fit down in here and hold the shaft while you tighten this up, and most 32mm wrenches are a bit too thick to slide in between there and keep this in the right position. So you might have to go buy one and then get happy with the angle grinder on it to get in there and hold it. But it's doable. I did it, and it rebuilt nicely. But yeah, they charge about $3,500 to rebuild one of these for you. I can see where the money goes. It's not a fast process, especially when you're having to heat shrink one gear at a time onto the shafts one at a time. You know, you got to put the shaft in the freezer, and then you got to put the gear in the oven, heat one up, cool one down, then you slide one on, and then once you've got one gear on, you got to put that shaft with the gear on it back in the freezer, put the next gear in the oven, warm that one up while the shaft cools down again in the oven, then you can put the other gear on. You know, if you try and push it on with a hydraulic press, you're going to destroy the shaft. Don't try it. It's not a good idea. So yeah, it's all heat shrunk and every single gear in there. Now the main shaft, to get the main shaft in that holds, it goes right through the gearbox, you got to cool down the shaft in the freezer. But before you do that, you've got to push the two main bearings on. Once those two main bearings are on, you cool it down, and then you've got to take the lower of these two plates and sit it in here, sit it into the bottom of this transmission. So this one you leave out, these shafts are left out too, and you drop that lower plate in, and once you drop that lower plate in, you bring the shaft up through the bottom, install the shims, the spacing shims, and the circlip to hold the main shaft in while it's still freezing. At the same time, you need the gears that go on the other side of that shaft. So there's two gears here. There's a bigger one, there's a small one here and a bigger one underneath. So the bigger one, I heated that up, and the smaller one, and the aim was to put that shaft in while it was freezing and get those two hot gears on it in one with that lower plate on first. Now as soon as I chucked that big gear on the shaft, that shaft cooled to a point, or it heated up to a point where the little gear wouldn't go on. I got the little gear about a quarter of the way on, and then it jammed up. So I had to go get a puller, pull the little gear off. Now I was stuck in a situation where the shaft isn't cold anymore, and the little gear isn't hot enough anymore. So little gear had to go back in the oven, and then to get that shaft cold, it's now fixed inside this housing. Like, there's no way to get it out without pulling off that big gear. So guess what I did? This whole gearbox that went in the freezer, I put it in there overnight, got it down to about 23 degrees below, which was really, really cold. And I heated the little gear up again, and it dropped straight on. So I took the little gear up to about 390 Fahrenheit, 390, 400. You don't really want to go over 400 because you'll interfere with the hardening on the gears. Like, if you go much over 400, you start to soften the gears. So 400 you cut off for the gears. You don't want to go 400 Fahrenheit, that is. So don't go above 400 Fahrenheit on the gears. If you go any hotter than that, you're gonna make them soft, and then they won't last. But it's doable. You know, it's not easy. Guys on the forum said it's not easy. They weren't lying. It's not easy. Would I rebuild one again? Yeah, probably, but not in a rush, shall we say. I think if this transmission dies now, then we might have a go at direct driving the machine, because they're not easy to find. You can get the gears from the manufacturer still. He still makes them. The guy there, Mark's a really nice, friendly guy. Spoke with him on the phone, give me some good advice on what to do and what not to do. He's not there to help you all day long. That's not what he's about for. But I would compose my questions on an email, and he checks his email once a day, and the following day he's pretty good. You'll get an email back and he'll say, yeah, do this or do that, and you'll get his recommendation. And I'd highly suggest you follow it if you're rebuilding one of these yourself, because you don't want to mess it up. But he's rebuilt tons of them. He designed the thing. This is actually a patented design in his name, so if anybody knows anything about this gearbox, it's him. He's got the patent on the thing with his buddy that he works with. So he's the man. You're speaking to the guy that designed it, not just the guy that works for the company. So yeah, overall pretty pleased. It's ready to go back on. The motor's over there. It's all been rebuilt, sitting there ready and waiting to go. So what I will say is this took longer than I thought it would. I thought it would be done in a couple of days, just pushing gears on and off with the press, but nope, it wasn't that easy. So yeah, if you ever need any advice and you can't get hold of Mark, or you just want an independent view on it, then feel free to contact me on the forums. I'm normally on CNC Zone. I'm AshG on there. But yeah, it's doable. You can fix them. And I'll keep the old gears sitting on the bench just in case this decides to self-destruct any time, because then I've got parts on hand to fix it. The sensors here and here, they're all readily available. I say readily available. The manufacturers still make them. They can be a little bit expensive. Usually if you hunt around on eBay and places like that, these things are used on all manner of devices. So there's new old stock everywhere. So this lower one, I've replaced it because the cable was gone here. It still worked, but it wasn't very good. But this one is an SR6-004 reed switch made by Pneumatics, Numatics. And then these ones up here are actually made by Turnac, who make the actual rotary actuator, and they're part number A177. And again, I got replacements on eBay. I've got them here. I haven't put them on because the ones that are on there are not broke. So this one was lightly used. You can see right there, A177A. And then I got another one. This is brand new, this one. It hasn't been used. So I'll keep these on hand, if they ever go wrong. Reed switches are moving devices. Eventually they do wear out. So, and I don't want to be with a machine that's down for several days while I try and get one for a reasonable price. So yeah, all in all, pretty good. On this seal here, you need to use like a black RTV or something like that. That's what I would recommend for there. The manufacturer actually recommends, so here on this top surface where the motor mates to this gearbox, there's actually a proper gasket, and that gasket's got some damping properties and it spaces the motor correctly for the transmission. Now this didn't have a gasket on it when I got it, and I guess whoever did some service work on it at some point took the gasket out and just put some silicone on, and that was also adding to the gear shifting issues, because if you go too mad with the instant gasket stuff, like especially around here and on here, it actually gets into this mechanism where it turns, and that inhibits it from rotating nice and freely. So if you're having real bad issues with it actually rotating, then take this top plate off, lift the motor off. So you don't have to undo the motor from here. What you can actually do is undo these four and just lift the whole motor in this plate off, and that'll take the actuator off too. And then you can just turn this by hand. Like if you just put your hand in there, I can't do it now because of this, but if I just turn it by hand, like you can feel if it's loose or tight. And without this actuator on there, that should turn fairly easily by hand. It's heavy, but you know, you shouldn't need both hands to turn it. You should just be able to kind of put your hands in there and turn it. If it doesn't turn like that, then it's gunked up, and that's what's stopping it from turning. The other issue as well is with the sump on these gearboxes. So the sump is split into 3 chambers. So you've got a chamber here, and then one there, and then one on the opposing opposite side. Now, the way these sumps are designed is that any rubbish or junk that comes off the gears, you know, as the gears wear, you get a bit of metal in there, it all goes down and settles in the bottom of the sump. Now, when you drain it from this drain only goes in to this sump, this side. So up until this point, you've got 2/3 of the sump that don't actually drain out. So if you really, really want to get all of the dirt and muck out of this thing, you're going to have to take the transmission off, fill the thing up with parts cleaner. Don't use a water-based one because it will rust, it's cast iron. So you're going to have to use some kind of chemically based parts cleaner, like a brake cleaner or something like that, a lot of it. Fill the thing up, let it rest a bit and soak all that out, and then turn the thing upside down and hope it all comes out. The other option is to take the whole gearbox apart, push the main shaft out and clean it out like I did. Now, to stop this happening again, I got an angle drill and I put a small hole between the passages in the sump. So you're still not going to get a swirl effect in there, which like the baffles in there are designed to stop you having a swirl effect from the gearbox. But there's just a small enough hole where if I actually undo this drain, the oil is going to drain out from the sump here and the other 2/3 of it. So I should be able to do better oil changes on this gearbox from now on. But yeah, I think had I designed it, I probably would have put a little passage between the two just so you can get all the oil out. But I don't know how important it is. It's 26 years old and it's only just needed a rebuild, so yeah, you could argue it's not really that important, but I did it anyway. I want this machine to last a few more years. I'm putting a modern control on it and refurbishing the whole thing. I might as well do it properly. But that's it. So till the next video, hope that helps anyone who's having shifting problems with their torque cut. But it's really easy, really simple, and yeah, if you're having trouble with it shifting, then yeah, hopefully this makes you feel a little bit braver about getting stuck into it. You know, you fixing a shifting problem on it should be easy. Rebuilding it, that's harder. But you can easily get to this. You can get the motor off. It's 4 bolts. These ones are harder to get out because if you look over there on the motor, you can see on that top piece there, that's all the space you got to get an Allen wrench in there. But you can get one in and you can get it out, but it's fiddly. I ended up pushing I took a socket kind of Allen wrench like this, but a shorter one, and I pushed the Allen part out of it, and then I put a wrench on it and turned it, and that worked. But yeah, you can take these 4 bolts out, lift that off, have a look in here, see what's going on. If you got one of those suction pump things, you can you can probably get down in here, and there is a few holes in there. If you get that in, you've got a sump which is here, so where the name badge is, if you can get the hole lined up here and get a little suction pump down there into that area, you'll be able to suck that area out. And then there's one under here and one under here in the bottom. So you see it's split, it's divided into 3 sections in the bottom. And to reference yourself on the division, this is the first division where the nameplate is and the drain is. So, and the others are opposing like that. So if you can get down, and you see down there's a few holes in there. Sorry, it's a bit blurry, but if you can get a little suction pipe down there, you can probably suck something out if you really want to get down in there and get as much as you can out. But if it doesn't look this colour, if it looks like an orangey colour, like all tanny and nasty, even black, then yeah, that's probably what's causing your gear change issues. But there's no reason why these shouldn't have trouble shifting. Well, there's no reason why they should have trouble shifting other than that the oil's gumming the thing up, or this thing's worn out. But I took this apart. The seals in it were worn, but not worn enough to kill it. The other thing I was having was I had an exhaust leak out of the actuators that are on the machine. Not the actuators, sorry, the pneumatic solenoid valves, the red ones that are on the left hand side of the machine if you're facing the front on the back. So one of those was letting air by all the time, and actually what was happening is on this shot pin the seal in here had gone in one direction, so when you had pressure coming in from the bottom to hold the shot pin in, it was letting past the seal and coming back here and then exiting the exhaust on the solenoid. So there was nothing wrong with that solenoid, even though I stripped it out and rebuilt it thinking it was that. It wasn't that, it was this shot pin. So that's solved now, so the machine will be airtight. I'll be happy because my compressor won't run all the time, and everything should be a lot quieter because the gearbox is rebuilt. Anyway, over and out. If you got any questions, then hit me up.